Well, now our discussion will start from the laws of motion. Now, we are emphasizing here on the first law and the second law of motion, along with certain definitions like inertia, illustrations of first law, the illustration of second law, their mathematical formulations, then what is momentum, the change in momentum, and how we explain these laws on the basis of calculus. So one thing is very clear that these laws were made quite long back by Newton, about in the 15th or 16th century. And at that time, whatever laws were made, the conditions were not applied to them. Now, what we find is that in the 21st century, the laws are not changing, but there must be certain modifications. Like one of the example we will take, a ball is dropped from certain height. The point to understand is we are dropping the ball, not throwing. When the ball will touch the ground, it will come to certain height. So if the ball is dropped from say 20 meters height, after striking the ground, it will come back and it will ascend nearly up to say 12 meters, 15 meters, but not 20 meters. So action was 20 meters, but reaction was not the same. So it means that according to the law, action and reaction are equal. But what we find that action was 20, but reaction is not equal to 20. So the law requires modification. When the ball will strike the ground, we are referring to rubber ball, when it will strike the ground, during the contact or during the collision, some energy loss will take place. And due to that energy loss, the height attained by the body after collision is not the same as it was earlier. It means that either collision is elastic or inelastic. Elastic collision is one in which there is no loss of energy. Energy is totally conserved. But in inelastic collision, there is some energy loss. And that energy loss is not, if useful, that is known as dissipation of energy. So when the ball will hit the ground, we will find there is slight energy loss, and that's why ball will not come to the initial height. So it means action and reaction will be equal if the collision is elastic, not otherwise. Similarly, we have to go through with the first and the second law of motion. Well, first law is basically the statement of inertia. Inertia means the state of body. If a body is in the state of rest or in the state of motion, it will remain in that state until otherwise some external force is applied to it. And the second law will be stated as that force rate of change of momentum is directly proportional to the force applied on the body, and the body moves in the direction of force. So these facts are to be discussed in this particular portion. So our topic of discussion is the first and the second law of motion. Well, Newton's first law states if a body is in the state of rest, it will remain in that state, and if the body is in the state of motion, it will remain in that state unless otherwise some force is impressed on it. The moment we impress a force or we apply a force, we find that the object changes its position. This we can depict in case of rocket. That is when fuel will come out, the rocket will start moving. So at the moment, rocket is in the state of rest. Now the rocket is moving, fuel is coming down, force is applied upward or up thrust is acting, so rocket is moving. So rocket is moving from the state of rest to the motion by the impressed force, and this impressed force is due to the fuel. So fuel is coming out and the rocket is moving up. So rocket will work when the force is applied or impressed on the rocket. Now we come towards the first law of motion. Everybody continues to remain in the state of rest or uniform motion unless an external force is applied on it. If a particle is at rest, it will remain at rest. And if it is moving with constant velocity, it will continue to move in the same direction with same constant speed unless an external force is applied on it. First law is also called the law of inertia or the Galilean's law. First law gives the qualitative definition of force. According to it, the device used for changing the state of body or the particle is called force. Or otherwise also, force is an agent which changes or tends to change the state of rest or the state of motion of the body. And now we come towards inertia. This is the property of all the material bodies by virtue of which it opposes the change of state. So inertia is the property of body due to which it maintains its state of rest or the state of motion. So inertia of a body is directly proportional to its mass. Inertia will be of three types: the inertia of rest, the inertia of motion, and the inertia of direction. When we speak inertia of rest, it means body is in the state of rest. It will not change its state until otherwise we will apply some force to it. And similarly, if a body is in the state of motion, it will not come to rest up to the time we will not exert force on it. And inertia of direction. In the inertia of direction, normally we take an example like a hound is chasing a rabbit. If rabbit is moving in straight line and hound is also moving in straight line, the hound will catch hold of rabbit. But rabbit, in order to save himself, the rabbit starts moving in a zigzag motion. So when the rabbit is in zigzag motion, it means that the rabbit is changing its direction at the different instants of time. Now when the hound will start chasing the rabbit, both are in straight line, but the moment hound approaches the rabbit, rabbit starts moving in zigzag motion. The hound will move ahead, and then the hound will sense that the rabbit has gone in a different direction. So the hound will come back and will start chasing in that particular direction. But every time the rabbit will go on moving in zigzag motion. So up to the time the rabbit is in zigzag motion, the hound will not be in position to catch hold of rabbit. But the moment rabbit will be in the same state of inertia as the hound will catch hold of rabbit. Now there are many examples. The passenger standing in a stationary car or train falls back when it suddenly moves. The passenger standing in a moving motor car or a train inclines forward when it stops suddenly. If a coin is placed on a cardboard which is placed on a tumbler, then on pulling the cardboard suddenly, the coin falls into the tumbler.